share those things, but all that I can say that he delivers excellent lectures. So today is more or less his specialization part. He will be talking on the sensors, transducers, and up to the latest topic, that the polymer related, surface related, and all those stuffs he will be talking. And he has delivered a similar kind of stuffs elsewhere. But what is its utility in Internet of Things? As you know that without sensors, we cannot really move in this particular topic in IoTs. And then we will introduce security aspects into it. So with that, it's now over to Askant. He will read out a little more on Professor Pati, and then he will hand over to Professor Pati.
Good evening, all. Good evening, Mahapatra sir and Pati sir. So I feel honored to invite Professor Umesh Chandra Pati as one of our experts. His topic is sensors and actuators for IoT. So let me just tell his brief bio sketch. So Dr. Umesh Chandra Pati is a full professor at EC Department, NIT Rourkela. He has obtained his BTech degree in electrical engineering from NIT Rourkela, Odisha. He received both MTech PhD degree in electrical engineering with specialization in instrumentation and image processing, respectively, from the IIT Kharagpur. He has also served as Head Career Development Center NIT Rourkela for 3 years. His current areas of interest are IoT, industrial automation, instrumentation systems, artificial intelligence, image or video processing, computer vision, and medical imaging. He has authored or edited 2 books and published more than 100 articles in the peer-reviewed international journals as well as conference proceedings. Dr. Pati has filed 2 Indian patents. He has served as a reviewer in a wide range of reputed international journals and conferences. He also has guest edited special issues of Cognitive Neurodynamics and the International Journal of Signal and Image System Engineering. He has delivered many keynote or invited talks in India as well as abroad. He has visited countries like USA, Italy, Austria, Singapore, Mauritius, etc. in connection with research collaboration and paper presentation. He was also an academic visitor to the Department of Electrical and Computer Engineering, San Diego State University, USA, and the Institute for Automation, University of Leuven, Austria. He is a senior member of IEEE, Fellow of the Institute of Engineers India, Fellow of the Institute of Electronics and Telecommunication Engineers IETE, and life member of various professional bodies like MIR Labs USA, the Indian Society for Technical Education, Instrument Society of India, Computer Society of India, and Odisha Vigyan Academy. His biography has been included in the 32nd edition of Marcus Who is Who in the World 2015. So with this introduction, I invite Professor Pati sir to kindly share his presentation and start it.
Your mic is off. Your mic is off. Good evening to all of you. Am I audible?
Yes, sir. Yes, sir. You are audible. Please share your slides, sir.
Okay, then. Good evening to all of you. And it's a pleasure to talk to you. And at the outset, I would like to thank Professor Mahapatra and Professor Swai for giving me the opportunity to talk to this August audience, and particularly Professor Swai for giving me an introduction. As I told you, it will be a pleasure to talk to you in this evening. In fact, it's not a talk, it will be a journey through different terrains. And in fact, this is sensors and actuators, because it's almost at the beginning of the program. So I have to cover a little bit more than that. And as you understand, sensors is at the beginning and actuator is at the end. So I cannot help but discussing about the intermediate sections, unless otherwise standalone discussing the beginning and end is not complete. So in the way of the traversal, I shall discuss about the ground level. I shall, because this is a heterogeneous audience. So from the scratch, I shall cover, and I shall go through industrial automation, then IoT, then industrial IoT, then how the sensors and actuators is useful and being developed over the time. So let us start the journey right now, and let me share the slide.
Yes, sir, it is fine, sir. You can go to full screen mode.
Yes, I have gone. And this MS team will take a couple of seconds to go to full screen mode. I think now
Yes.
it is full screen.
Yes, sir. Yes.
Yes. So first of all, let me discuss little bit basics, and time duration is completely more. So as I told, as I'm delivering to heterogeneous audience, let me start little bit of scratch, little bit of beginning. So what is the instrumentation system? In most of the applications, many of the physical quantities need to be measured and to be controlled at a particular desired value. The reason is that we should maintain the desired product quality, composition, color, so that clients will be satisfied. So first one is the product quality. Second one is the production rate at minimum cost. That should be looked after, because you cannot be so slow or too fast. And then last but not the least, safety of the workers, operators, as well as the equipment. We cannot sacrifice the safety, because safety comes first. Production quality, production rate comes later on. And these things are needed. And that is the reason why we are discussing this particular topic. So as the previous case discussed, it has got two segments. One is measurement system, sensors. So this is the prime element. And it takes very less amount of energy from the medium, from the process, for the variables which we are supposed to measure, and produces an output. And it is proportional to the quantity which we are measuring, particular physical variable. So the blocks are like that. So this is the process of the medium in the left-hand side. Then you have connected a sensor. Then we have connected with signal conditioning. Then we have connected with signal processing. Then this is display. So this is the minimum block diagrams which we can have. We'll extend to this, particularly the display part will be replaced by computer later on. But basically, when before the advent of computers, this was the case here. So there is a signal conditioning and signal processing blocks here. Two independent blocks, but most of the time we tell signal conditioning or signal processing like that. But there is a thin line differentiating signal conditioning and signal processing. Every sensor that require either of the one or both, signal conditioning is mandatory, signal processing is optional. Why it is so? Let us distinguish between what is signal conditioning and what is the signal processing, and what is the thin line dividing both, and what are the functions under this head. So signal conditioning provides operations. And as I told, it is mandatory. Transform from one form to other form or level. Subsequently, we can interface with other modules. And common operations are amplification, filtering, isolation, scaling, and attenuation. The names are familiar with many of you. And then what is signal processing? These are phase sensitive detectors, peak detectors, RMS converter, frequency to voltage, local to frequency, voltage to current, current to voltage converter, and logarithm amplifiers. These signal processing, as you told, it may be required, may not be required, but signal conditioning is bound to have. It is definite. We should have signal conditioning after its sensor before going to subsequent blocks. Then finally, the display, it should be appropriate unit, and it can be analog, digital for instantaneous views, or strip chart recorder, plotter, or printer for offline analysis. Either we can online analysis or offline analysis. That is the basic block of a measurement system. That is then control system. These are all a little bit basic on that. Closed loop and open loop. Nothing much to tell about that. So the sketch itself, the figure itself explains much of the aspects. So we have got a set point, we have got a controller, then here is the term actuator. So sensor, then it comes to the actuator, then the operation, and it is the control variable which has to be maintained at the set point. So this is the disturbance here, and we have got a feedback as far as the measurement is concerned through sensor. So comparison is being done at the controller, and correspondingly appropriate action, proportional action is given to the actuator. It is only for the disturbances we are supposed to do all the operations. Without the disturbance, there is no harm, nothing should have been done. Once you have set a variable at a particular point, it should have been stayed indefinitely. But this is not practically the same. Just an example of what we are going to do. I'm just discussing the gradual upgradation from normal industrial automation to IoT, to industrial IoT. Then what is the role? And in between, I also discuss about the sensors before telling what are the sensors, classification of sensors at the end and actuators at the end. So here in this case is an example of that. And it is a heat exchanger. It is known to everyone. Almost everyone knows this in this domain. So we have got a process stream which has to be heated up with the help of heat exchanger, and the medium is steam. So steam will be used to enhance, increase the temperature of steam stream. So here, as usual, there is a sensor at the beginning, transmitter, in processing, make it compatible with the to be sent to the controller. Here is the controller. So different type of controllers can be here, and recently PC or computer has replaced all other earlier controllers. We have got a steam flow, and this is what the final control element here. It is the final control element. Here is a valve. So this process is simple. So the valve has to be increased or decreased depending upon the temperature of the process steam. What you have to do so that flow of the steam can be controlled through the valve. So naturally, valve is a final control element or actuator. Same. In these cases, in fact, the operator can do the job. But the problem is that particular big industries, they have got plenty of variables to be controlled. So how many operators we can employ? So to reduce that, that is the role of automatic control system or industrial automation, in which measurement are controlled to essential segments. And as you have understood, sensor, it is the primary element, transmitter is the secondary element, controller, it is the brain of the control system. All the decision is being made here, and final control element takes the action. It is just like a slave to the controller. Sensor, it's just like our 5 senses what we have got to assess the environment. Like that, sensors will be there. Our hand and leg, they are behaving like a actuator. Controller is the brain. So the steps are minimum basic operation, measurement, measure the variable to be controlled is a combination of sensor and transmitter. Then based on this measurement, in fact, whether it is a simple system or a complex system, recent system, even if it is the involvement of IoT gradual involvement activity, the basic operations remain same. Then decision, as I told, controller decides what to do and what not to do, so that desired value will be maintained, and based on the decision, the action has to be taken by the final control element. And the terms which are important in this aspect are controlled variable. That is the variable to be maintained or controlled at some desired value. That means in the heat exchanger example, what we have given, this is the temperature of the process stream. That is the control. That is control variable. What is manipulated variable? The variable used to maintain the control variable at its set point. Then the flow of steam, quantity of steam is the control variable that we can control so that the process stream fluid can be at its set point. Then as I discussed set point, it is the desired value of the control variable. That means it is 35 degrees centigrade, 40 degrees centigrade, what should be the temperature of the process stream or fluid. Disturbance or offset. So that we understand it is the variable that causes the control variable. That means the temperature of the process stream to deviate away from the set point, 35, to deviate from the set point to 35, 37, 38. Then we have to bring back to, let us say, set point is 35 degrees centigrade. What are the 4 important terms associated with any control system, any automation system? This is little bit initial level of discussion. Then we go over to the industrial automation. So now, as you told controller, now PC has replaced all automation processes. And it is combined with networking. In that cases, wide range of industrial measurement and control problems can be solved. With this combination, network, data acquisition and control, that means network industrial automation. We can handle automation of process industries, manufacturing industries, buildings, locomotives, automobiles, avionics and whatnot. So all the things can be automated by the process. What it requires? It requires integration between different levels, different domains of a complete process plant. Production maintenance, plant maintenance, account maintenance. So all these different domains should be interconnected. And we need this sharing. Then what is the hierarchy model? So in this hierarchy model, we require flow of information between different levels. I shall tell the levels later on. It is from field device level, that means lowest level, up to enterprise level, that means highest level. I shall discuss about the levels. In fact, we shall discuss here, we shall discuss between IoT, we shall also discuss about the industrial IoT. All there changes has occurred, but basic things remain same. So there is a 5-level hierarchy. Here in this cases of industrial automation. So the hierarchy model, what it describes. So what is the equipment to be required? What is the network to be used? How the communication between the equipment can be established? what should be the quantity of information flow, and how control can be achieved. So what are the 5 levels of automation? This is communication hierarchy. See at the bottom. So there are sensors and actuators. They are at the field level. They are the soldiers, workers in a process plant, scattered across the industries. Then after that, there is a IO level, input output level. Third one is the control level. Fourth one is the HMI level. I shall explain this one. And last one is the enterprise level. We need information flow, communication between all these levels, so that, as I told at the beginning, product quality, product rate at minimum cost, and safety can be achieved. So the 3 points which I have told at the beginning, this is the major reason why we are going for all these businesses. So as I told, the initial is the field level. Then IO level already I have told, and HMI level, it is plant management or human machine interface level, HMI, human machine interference. Also it is called plant management level. Some management is occurring. In fact, all the names satisfied their nomenclature. We shall discuss about each one. And last one is the enterprise or corporate level. So what are the basic functions? And as I told, even if we graduate over IoT, industrial IoT, there will be minor changes, but basic construction, basic function will remain same, and levels almost here and there. Basically will remain same. So the first of all, as we discuss, this is the field level. So it is the lowest level in the automation hierarchy. And what are the equipments I have already told? It is field instrumentation, that is called sensors and actuators, workers for process measurement and control. So these sensors generates process variable. And what are the process variable? Temperature, pressure, level, flow. There are many more. Major one is this one: temperature, pressure, level, and flow. And these signals, what they received by the sensors, is passed to the input output level. This is the job of the sensor. They have passed on the information to the IO level. Then what are the role of actuators there? That receive signals and particularly control signals from the IO level and perform control operations. Some few examples are opening, closing valves, switching on off motors, etc. So this is what field level, and it is, as I told, scattered across the industry. Then IO level, input output level. Main function is that it's a buffer interface between control level, field level. It collects input signals from sensors and transmit to the controller. Little bit of processing is supposed to be there. Then a reverse way. Collect control signals from the controller. That means third layer, control layer, and pass to the actuators. Then the more important segment, control level. So the input is from the sensors are processed and control signals are generated. Main decision making is being done here. Few examples are PLC, distributed control system, and now the PC has been replaced. So data from all parts of the industry collected and presented to the computer. So as I told, This is in-process control. That is control level. In fact, for small industries, these 3 levels are minimum to reduce the cost. But for big industries, like the Rourkela steel plant here, we need 2 more. What is the 2 more? The next one, 4th one, is the plant management or HMI level. So in this plant management or HMI level, it collects plant data from the control level. All the data that are being collected here. Mark the word, human machine interface or plant management. So example of that is SCADA, supervisor control and data acquisition. And this program display plant schematic. That means all the variables on the monitor screen, control room. So the operator can sit there and have a look over the status of the plant, all the variables on the screen. So what it display or the process variable are different field points, not only a single point across the process plant, and also it gives a warning if some threshold value exceeds. That means pressure goes above the upper limit. So which can give rise to accidents. So all the things it has to be done and it has to display in the HMI level. Operator will able to know everything. That is the reason why it is named at human machine interface level. The last one, we have our product. It is of best quality. Rate is good, but we have to market it. We cannot keep it in our store. So this is the place enterprise level. This is office management world. That means it will be accounts and sales. So in that level, what are the things we require? Spreadsheet, text editor, emails. So that is what the job is there. So that is the 5 hierarchy model for the automation. And here, as I told, 5 levels are necessary for large industries. And the ability of different networks is also different. And it can be classified to data network and control network. Let us distinguish between data network and control network. So data network, in this case, it is huge in volume. Data transported is huge in volume, but not time critical. Time criticality is not there, but amount of data is too much. And the network is used intermittently. Where this can be used, let us say enterprise level. So you can send a lot of volume of data, but sometime here and there will be okay. And it is also not continuous basis. In contrast, control network, amount of data is less, but it is time critical. That means it is the control signals which is being sent to the actuator. And it is time critical, amount is less, and the network is in constant use. A particular variable is constantly monitored and controlled. Example, temperature. So that is data network and control network. So basically this structure remains same for all. Then we come over to the step ahead. That is the inclusion of Internet of Things. I shall just give a bird's eye view, glance over this, because we are having a transition, gradual transition to the recent automation process. So these days, IoT has become a buzzword. So billions of people buying mobile devices, and it gives rise to immense processing power, storage ability, capability, and knowledge. So all sorts of physical devices can be interconnected by IoT, like appliances, vehicles, even human beings, with the help of sensors, actuators, and software. And that becomes a network. And in this process, the physical devices, they communicate, interact, process, and exchange all the things they are supposed to do among themselves. And this technology supports that. So what is the IoT definition by IEEE? It's a self-configuring and adaptive system. And it consists of sensors and smart objects to interconnect all the things. And by doing that, what we achieve? These devices that becomes intelligent, programmable, and more capable to interact with humans, human-machine interface. That is what the ability will increase. It has got wide range of applications. All the fields, all the domains which you see, IoT can be applied there. Agriculture, healthcare, to name a few: agriculture, healthcare, manufacturing, transportation, environmental. As I told, all the fields which are able to see. It is not like that all are good for IoT, but one point which need to be addressed: interoperability. Because a lot of devices, different characteristics, they are being used. So there should be interoperability among devices. And we should be able to process the huge amount of data. And the way IoT is advancing, we can expect that around 25 billion. So total number is globally is 25, and it will be 25 triple by the year 2025. So that signifies why we should able to handle this colossal amount of generated data. Day by day, it is increasing. So the exact word of IoT is anytime, anywhere, anything. Anytime, anywhere, and anything. And it should sense the environment and also affect the environment. That means measurement and control. And it's an intelligent way. So in these cases, these smart objects, which can be remotely monitored and controlled, and indirectly, it makes our life smarter, and we gain complete control over our lives. So IoT is growing network of everyday objects, all the things industrial machine, consumer goods. In cases, the functions are: smart devices collect data, relay information or context to one another, process the information with collaboration of everyone. Then finally, prompt operators or machines for further actions. So as I told, heterogeneous devices, it has to connect. The layers of IoT: sensing layer, networking layer, service layer, interface layer. So let us discuss a little bit on each layer briefly and have a look at this IoT architecture. Sensing layer has got few devices. Networking layer has got few. Then service layer, then interface layer. Let us discuss with reference to this sketch. Let us discuss a little bit on these different layers of IoT architecture. So the word is sensing. Nothing new to us at this time. So it has got IoT devices. Already I have discussed about the field layer. That is almost similar to that. So IoT devices equipped with sensor nodes. All the devices, what is there in the sketch? We have just discuss Bluetooth devices, scalar, analog, digital, all sorts of sensors are there. And in fact, the same node has this same function as the sensor has to do, sense the information, transmit it real time and communicate among themselves. And in fact, in these cases, it consumes low power and does not require much data rate connectivity. Here the sensor nodes from WSN, and based on the application, the sensor modes can be grouped together. Then the next one is the networking layer. So the networking layer helps the IoT devices to share the information. And here itself, this amount of data which has been generated in the lower level are handled by this layer. So it consists of what this sketch indicates: social network, mobile network, wireless LAN, internet, and database. It should have low latency. It should have given rise to scalability. That are the requirements of IoT application. We should take care of bandwidth requirements, energy efficiency, as well as security. IoT security, in this case, it comes over. And the service layer integrates the services and applications. And mainly it operates on overall workflow. As I discussed in the previous, information exchange, communication, storage, and management. And also in this layer, one important task can be done: predictive analysis. We can predict different aspects of machines, devices. And the next one is the interface layer. So as you have got interoperability, different type of devices are there. Interaction has to be there among themselves. And day by day, it is increasing. It is not static. How more devices we have today, it is increases. And that is the difficulties in connecting, communicating, and operating. This layer systematically streamline the management and interconnection. So basically, these are the layers, little bit of idea about the IoT. Then we upgrade to industrial IoT. So in these cases, just a little bit of upgradation. I shall also show the difference between IoT and industrial IoT. And in fact, IoT forms the base for Industry 4.0, industrial internet systems, or industrial Internet of Things, industrial IoT. So in these cases, almost function same. It can monitor, collect, exchange, analyze, and act on information intelligently without human intervention. So what are the objectives? Improved working conditions, we understand that. Better product quality, how it will be achieved, we shall see. Minimization of energy consumption. Enhancement of machine lifetime, that is important. Energy consumption should be less also. And overall upgradation of operational efficiencies. Then this is the industrial Internet of Things. And here also, there are different layers. Device layer, gateway layer, edge layer, and cloud. See this setup here. So let us discuss each layer individually. So the device layer exactly similar to the field layer, what we have discussed in industrial automation, sensor nodes. And it has been employed within various machines and devices. And then this device layer transmits data to the middleware level. In fact, edge layer and cloud, they combiningly to the middle layer level through the gateway devices. And this infrastructure is at gateway devices, Wi-Fi, LAN for further processing. As I told, the edge layer and cloud together is the middle layer. And what the job they are supposed to do? Analysis, storage, and processing of data. So cloud platform providers, just for a few example information, this is the name of the providers: G-Predix, Siemens, Sphere, Honeywell. Just few examples of that. Software development firms, these are the software development firms. You can have a look at that. And sensor, these are just few examples. GTS, Honeywell, Omega, Bosch, and Different. And their actuator manufacturers, these are the actuator manufacturers which are supplying the actuators. Then the comparison between IoT and industrial IoT. Not much, but still have a look at this. Most of the cases, not on all the times, this is for well-being of individuals, IoT, but this is for industries, industrial IoT. Mainly keeping an eye on the devices developed for the improvement of three things: efficiency, safety, and security in industries. Then interoperability. So machine to machine is in small scale, but in industrial IoT, it is in a large scale. Scalability. Industrial IoT is in small scale, but in industrial IoT, so it is seamless integration. Seamless integration in the sense go on increasing, not static. So in only IoT, it is in small scale, but industrial IoT in a bigger scale, larger scale, and it is scalable day by day. In IoT, have a look at this point: automation with limited or no human involvement. But industrial IoT is a step ahead again. In addition to that, intelligence of, that means control automation, logic, deep learning, and analytics. So that the things have been included. Then application, it is generally for consumer purpose. It is for industrial purpose, industrial IoT. In case of emergency, in IoT, if a device fails, an emergency may not occur, but here it will occur. So those are the basic differences between IoT and industrial IoT. So this is approaching 8. Can we take a short break here? Ashkan, are you listening?
Yes, sir. Yes, sir. Yes, sir. We can take it.
So just I'll come back.
Yes, sir.
So just I'll come back soon. I'll carry on from this one. Just I'll come back within 5-7 minutes.
Okay, sir.
I'm again back. Am I audible?
Yes, sir. Yes, sir. You can start, sir.
So, yeah, right. We have discussed about the industrial automation, then IoT, then industrial IoT. Then let us discuss a little bit of industrial processes. So that means it covers all the ranges: physical, chemical, mechanical, and electrical. All the processes has to be combined together for a product, as I have told, and on a large scale, product on a large scale, as I told, production rate. And in these cases, industrial IoT, everything again it sticks. Product quality, safety, and production rate. As I have told at the beginning, whatever things may change, but these three factors remain unchanged. So in these cases, the key features of industrial processes, what should be the key processes and features of industrial IoT? Distributed decision generation for software and hardware. In these cases, smart and intelligent devices, IoT devices, they can generate their own decisions autonomously. And in case of interruption, the decision of the higher level may be needed. Then second point, what is required for industrial processes involving IoT is that the transparency of information to the operators. And here what is helping? Real-time data and information on the various manufacturing processes. Operator can identify the errors, malfunctions, and degradation in the processes. Then the word interoperability. So a lot of devices from different manufacturers are used here. And that has sensor nodes, intelligent machines, and people. So they should be able to communicate, transfer, and connect with one another. And that should be a standard communication protocol. And last, technical assistance. It will help the operators to make the decisions independently with minimum or no human intervention. So in these cases, industrial IoT connect the industries and other organizations with the help of internet. The future architecture, various layers of futuristic industrial plant. Have a look at this. The lower one. It is all production, then automatic packaging, then storehouse, warehouse or storehouse, supply chain, distribution. Over that, this is systems, then analytics, then we inspect the product quality, then use security and take the feedback. Last one, through cloud and data security to the end consumers or consumers, customers. And in the right hand side, these are the functions of this future architecture. So again, 5-layer. At the beginning, we have seen a 5-layer. Now again, a 5-layer future architecture. How it should look like and what is the deviation. The layers are connection layer, conversion layer, cyber layer, cognition layer, and configuration layer. A brief outline of the functions has been mentioned here. The detailed description, let us have on this. So the first one is the connection layer. So the sensor node machine and other physical devices. Through internet, they are connected. So earlier we have discussed actuators, sensors. Here also same, almost same. And operation is also same. Continuously monitor the autonomous operations. Normal as well as hazardous environment. And main concern is the health hazards can be checked. Then conversion layer. Almost similar in the earlier cases, extract meaningful information from the collected data. From the first layer, it collects the meaningful information. And then complex analysis of the data. How it helps us? Estimate the health of the machines. How long it will operate. In fact, last one is the lifetime also. So health of the machines, predict fault also. From the history, from the previous assessment, it can also predict. Then forecast, which is the remaining lifetime of machines. This is the important task, health monitoring. Status of the health of the machines, all sorts of business it has to do in here in this layer. Then cyber layer. Little bit more information, additional meaningful information with a deeper perception. And this is in fact the main information center. So your previous layer was able to predict the lifetime. Here, future performance of the machines can be predicted. And one more important function of this cyber layer is the security of data. Data security is important here. Then cognition layer, diagnostic and decision making. So in this layer, complex analysis, remote monitoring, integrated simulations are supposed to be done. So, and in these cases, the analysis helps us to prioritize and optimize the decisions. And here complex analytics applied to predict faults and downtime. Also, it has got important application which can predict market analysis, future demand of users, forecast new business opportunities from the market trend, and how we can improve the product. And the last one, configuration layer. It provides feedback from cyber layer because we need a feedback cyber layer to connection layer. And as usual, the feedback helps the machine to two important tasks, self-optimize and self-adapt to the changes. So feedback only helps in this process. So these are the 5 different layers of industrial IoT for future industries. Then let us come over to the industrial sensing. As usual, monitor and control. Actuators combined together, monitor and control. Then traditional sensing, little bit developed. So in these cases, the things same, but a little bit developed in the previous cases. So which minimizes again human involvement. An example is robots can be programmed and deployed to perform tasks in hazardous conditions. In these cases, the initial cost of automation is relatively high. Then bit of development about that, contemporary sensing, smart sensor nodes connected to the internet. The terms like cloud, edge of the network comes into picture. And here the analysis helps about the product lifetimes, safety condition improvements and reliability. And in these cases, wireless technologies are important. So in this particular container spring, in smart sensor node, microprocessor at the core. Smart sensor nodes also minimize power consumption, and it can also delete data at periodic intervals to save the memory space. Smart sensor nodes are small in size, and it can handle large amount of data. Plus points of smart sensor nodes. A definition of the smart sensor node can be goes like this. It's quite a specific output when interfaced with the hardware. And it can also range and calibrate data through a system, autocorrect. Everything can be on its own. So it transforms real-time data into stream of transmission, and gateway helps in this process. Have a look at the sketch of a smart sensor node. I think by the time it is in your screen now. So the flow of information, sensing unit, sensor, analog detection circuit, then interface, signal conditioning. Then here is the role of analog to digital conversion. Most of the sensors, they provide analog signal. Microprocessor is the core. Then again, digital to analog conversion, and then actuator. From the figure, it can be understood that it has got sensing unit, interface module, processor unit, and communication unit for a smart sensor node. Microprocessor is supposed to do filtering, compensating, and processing. These nodes are also known as system on chip because they're all combined on a single silicon wafer, small in size but handling large amount of data. What are the applications of smart sensor nodes? Roughly 5 applications has been mentioned here, but the domain is more. Not possible to discuss everything. Agriculture, healthcare, retail, supply chain, manufacturing. And few examples in agriculture here are location. We shall discuss a little bit more regarding the applications, particularly the principal applications we will discuss more. Location, optical, moisture level, water level. So that are the 4 important things which need to be monitored or controlled in agriculture. Healthcare, ECG, EMG, oxygen saturation, galvanic, skill resistance. Retail, proximity, RFID, GPS and light. Supply chain, motion, temperature, humidity, acoustics. Manufacturing, smoke, temperature, pressure, and proximity again. So let us discuss a little bit the application of these sensor nodes in all these 5 important domains. First of all, agriculture. See the applications used to monitor and automate the agriculture process. Monitor as well as automate. And it can also decide how much is the amount of fertilizer and what are pesticides, etc. to be applied. And overall, like machine health, It will decide the crop health, how it is, what else is required for a steady health of the crop, steady growth of the crop. It can also tell the farmer the best time of cropping. And generally the sensors I have given also the level. It can be position, it can be optical, moisture level, water level, because that is how much this moisture level is there in the air or in the land, or water level. All sorts of data which a farmer is supposed to know, that can be available at the fingertip. Then healthcare. So intelligent sensor nodes to continuously monitor the health condition of the patient remotely. So not only monitor, also alert any change or anything critical is going, any alarming condition is going to develop for a particular person. It can help the relatives, doctors, hospitals, etc. for this category of healthcare monitoring. It has got an abundant use these days. Few of just examples are continuous ECG monitoring, EMG monitoring, oxygen saturation, which is an important factor and quite being used the term in last COVID case. Then galvanic skin response, which is used in lie detector. That means from the resistance of the skin, we can know the status, physiological and psychological status of a person. So these are various sensor nodes which is being used for healthcare. These are just few. There are a lot. Industrial. Again, same thing, rate, quality, and safety, security of workers. So that is being used, that is being fulfilled by this type of nodes, and many of the sensor nodes which is being used for different variables like temperature, pressure, level, flow, as I told, and they are supposed to monitor the industrial processes. We have discussed a lot before that. Then supply chain and logistic. So monitor and track logistic and related activities, and will help us. All the marketing activities, optimize supply lines, avoid also theft or misplacement. So we can have sensor nodes will avoid the misplacements, and overall it increases the efficiency. We can have also proximity sensor, vibration sensor, RFID tags in this supply chain. Then let us come to different type of sensors and actuators. So we have gone through different. This is the last segment of the discussion will be there. So whether it is IoT, consumer IoT, or industrial IoT, we have discussed that sensing is the first step and actuation is the last step. We have discussed about sensor and actuators earlier. So already we have discussed these things. Few lines about the sensors. So characteristic of the sensors in general. First of all, the sensor calibration. So this is to remove sensor errors. And inherently they have some sensors have some during design. And the error is how much should be the expected value and how much is the output value. Expected value can obtain from an ideal sensor. Same operating condition, almost all, and this is perfectly ideal. So in that context, we can enhance the accuracy of sensors in real-time operation. Have a look at this sketch here. This is ideal characteristics between input and output. And in the right-hand side, dotted line is before calibration, which is deviating much from the ideal. And the lower one, solid line, is the after calibration. One characteristics is sensor correct, that is a calibration. The next profile, sensor profile. What is the expected trend and behavior of the sensor? It can be linear and non-linear. The left-hand side, input is proportional to output. In fact, we want the sensors to be linear. In the right-hand side, the input-output relationship is nonlinear, logarithmic, exponential. So different amount of increase in output at different instants of input, but here in linear, it is uniform same. There is process by which nonlinearity of the sensors can be linearized. But broadly, the two type of sensors can have the two profiles, that is linear or nonlinear. The accuracy of the sensor. In fact, degree of correctness or closeness, a sensor can quantify. If the actual reading is 100, then if it is 99.5 or someone is giving 103, then the earlier one is more accurate. Sensor resolution. Intensity or level of details to capture 3.25 in comparison to 3.32. So it has got more sensor resolutions. A rating, maximum and minimum values of the different conditions which sensor can safely handle. If rating is up to maximum value 200 degrees centigrade, if it will go beyond that, there is every possibility that it will damage the instrument or it will malfunction, it will not give the reading accurately. Then many of these sensors, they are supposed to operate in a particular voltage range. And again, if we're exceeding that, there is every possibility of damaging the circuitry, knowingly or unknowingly. If there is any impulse or something else, there is possibility of damaging this. And output, last one. So it is can be analog or digital. So already we have discussed that analog and digital, nothing much to tell about that. Then another classification of this one, that power requirements, sensor output, or measure property. Little bit more discussion on that. Power requirements. So some sensors, they need separate source of power, whereas some sensors do not require. And based on this power requirement, it is divided into two categories: active sensors and passive sensors. So active sensors do not require. That means it has got independently, it can work on its own, convert the particular one form of energy to other. Any sort of device like photodiode, as the example is given, it can convert. Passive sensors, in fact, it needs, unless otherwise it cannot operate. And the example is that thermistor, an external voltage source is required to measure the resistance, division of the power requirement. Then depending upon the output. So all modern day processors are digital. So that means digital sensors are preferable. But all sensors, they produce analog signals. So for any IoT nodes, we need an analog to digital converter. And this will be divided into two categories. Analog sensor correspondingly the output which you are having, it will be divided in two categories, analog sensor and digital sensor. So as the name indicates, each output is proportional and it is continuous in magnitude. All the physical quantities what I have seen, that comes under analog signal. But there are digital sensors which output in discrete time, amplitude, or both. So it can be 1 or 0 for on off, but also it can produce single bit or 8 at a time, forming a single byte. One is for serial transmission, another for parallel transmission. Then depending upon the major property, sensors can be classified. So this is where a decision has to be taken. And in that cases, few properties, they have spatial variations, can be quantified based on only temporal, either temporal or spatial or both. And only temporal variations, examples are ambient temperature, atmospheric pressure. Spatial variations, which will take care of that later on. And sound, image, they have got both spatial as well as temporal variations. So depending upon which type of signal data we are measuring, it can be divided in two types: scalar sensor and vector sensor. So in that cases, only magnitude of signal is sufficient to characterize the phenomena, which has then only magnitude. And we have already given pressure, temperature, strain. Spatial information is not needed in this type of measurements. That means whether you are changing the direction of sensor or orientation, it hardly affects. That is what scalar sensor. But in contrast, vector sensors responds to the changes in magnitude of the variable as well as direction or orientation. So that means in these cases, we need additional information so that we can get complete information about the variable or the particular phenomena. So take an example of that. Electronic gyroscope. Example in modern aircraft. So it changes the orientation of gyroscope with respect to Earth's orientation. So those are the classification based on either spatial or temporal information what we require. Then for the classification sensors, there are long list of sensors, but few have been categorized here under the head of thermal sensors, mechanical sensors, electrical sensors, chemical sensors, optical sensors, and acoustic sensors. Each name signifies one property, and it is understood from their name itself what sort of sensor it has to for a particular IoT application. Thermal, mechanical, electrical, chemical, they themselves speak enough about the sensors which are supposed to be followed. But still, we shall discuss a little bit on this. Thermal sensor. So it depends upon the thermal energy. And examples are plentifully available. A few examples are RTD, thermistor, and thermocouple. And its application is many. As the application it shows, food, beverage, and pharmaceutical industries. In these cases, what the function is supposed to do, the product is at its correct temperature. And in machine tool and automotive applications, we can measure the temperature or temperature difference, absolute temperature or temperature difference for drives, gears, or motors. It will give us a information about its health of the particular machine or machine condition. Another example is that steel, metal, or glass industries. In that cases, continuous temperature monitoring and control of the cooling circuits. Cooling circuit is very important in almost many of the applications. Overheating will be avoided. So these are all few just examples of thermal sensors. Then let us come on to the mechanical sensor. So as the name indicates, changes in the mechanical properties has to be quantified. And some of the common types, there are others also, some of the common types show pressure sensor, and particularly pressure changes in gas and liquids. It can be piezoresistive. Few of the names are piezoresistive, piezoelectric, capacitive, electromagnetic, elastic, or strain gauge. Responds to the changes in pressures. The next one, flow sensor. Particularly when you speak about flow in process plants, mainly it is liquid or gases. Volume flow rate. Mass flow rate is less used. Maybe the grinded particles on a conveyor belt, but volume flow rate of liquid and gases are extensively used. And the use is coolant and lubricant supply of plants. Just an example of that we need to monitor how much supply is being done. And these flow sensors tells us if there is any flow interruption. And if there is flow interruption, it can damage or cause downtime. That will be restricted. So it is simple monitoring as well as precise flow rate measurement. And there are few examples. Common examples are orifice plate, nozzle, venturi tube, electromagnetic and ultrasonic, etc. There are many more than. And example of that, one more is there, rotameter. Have a look at this sketch, rotameter. So venturi, all things they are constant area variable pressure, but rotameter is just reverse to that, opposite to that. Variable area, constant pressure flow meter. Electrical sensors. After that, the property which we have discussed, that terms come electrical sensors. So it depends upon the electrical property of the objects. Few of the known sensors are inductive sensor, and it is free from any wear and tear. This is also insensitive to vibration, dust and moisture, plus point of inductive sensor, and invariably detect all metals, inductive metals. It has got a large operating range and it needs little protection for harsh industrial environments. Then one more common one is the capacitive sensor. Again, it is non-contact detection. Inductive sensors has got a restriction only metallic objects. But here it can detect non-metallic metals as well. We can find this application in like wood, paper, glass, plastic. These are the common industries where you can find the use of capacitive sensor. And also it has got high noise immunity. Few of the salient features of capacitive sensor. Then one more electrical sensor under this said magnetic sensor. Detection of position. But it will not be with contact. And when this is not contact, it avoids wear and tear. It also covers a large sensing range. It can also detect through walls. Either it is stainless steel or any sort of that can detect. And it has got magnetic sensor. It has got high mechanical stability and which is required when there is shock or vibration. And last example is that PIR motion sensor, passive infrared. And it is used for detect movement of human or living beings, any sort of human beings. So it has a long range of measuring. Power consumption is 65 milliampere and it's a large operating range. Next one of the list is chemical sensors. Here in these cases, it estimate and first of all, it detects the presence, whether the particular gas is there or not, particular chemical is there or not, and also it also estimate the amount. So it can use its resistive chemical compounds and Sorry, extremely sorry. There was an interruption in the network. I have changed the network. So am I audible?
Yes, sir. Yes, sir.
Yeah, right. I have used a different network now. So I think I should share now. Is it visible?
Yes, sir.
So we do not have any control over external factors. So there was a small interruption. So as usual, there are different sensors. As I told, carbon dioxide, methane, alcohol, etc. Then next one is the optical sensors. So it characterizes the optical property of an object or the environment. And few are azotic light sensor, intensity of light, infrared sensor, color sensor, camera itself is a color sensor. And one more sensor is there, intensity of red, green, and blue bands of optical wavelength. This is an example of comparison of incident wavelengths, 100%, 90%, 80%. These are all optical sensors. Few more optical sensors, 2D sensors, vision sensor, and it is used for assembly and manufacturing task, as well as quality control, because this 2D sensor camera is extensively used in industries. It can have contour verification and also presence, position, and size monitoring, quality control, sorting, as well as counting tasks. How many products we have obtained, whether these are of desired quality or not. Fault finding is also a task here. It can be used for product tracking and identification. It can track a particular object and it can also identify what is there in the subfloor. Then extension of that, 3D. It detects the volume, distance, and level. And for the distance, for this 3D, generally they use time of flight principle so that we can know the depth of a particular point on an object. So point to point gives a total complete information about the volume. So it will have an incidence rate and the time of flight will be measured. So it can be used for, as I told, volume determination, sorting task, and also collision avoidance, robotics, and monitoring of persons. It can also check whether a box, store box, contains adequate or correct number of items or not. And in fact, we are not bothered about the color and texture of the product. Still, it will count. And when there is an automated storage space, the sensor provides the size, orientation, and position of the packages. So in that context, we can optimize the space, available storage space. So this is about the optical sensors. Then acoustic sensor. So it converts the pressure changes due to vibration and sound waves. Examples are microphone we are using, seismometers, seismic waves, earthquakes, ultrasonic sensors. Just a bit of explanation on ultrasonic sensor. These are used for reliable position detection and precise continuous distance measurements. So it can have a exact position as well as distance. What sort of material it is immaterial. And it also transmit and receive sound waves, and time of flight will decide. And from that, we can get the distance information, acoustic sensors. Then, two lines on ultrasonic sensor. Even in harsh conditions like dust, mist, or soiling, the object can be detected. And it is independent of color, transparency of surface, and all other things. And it has got a large detection range. So these are few, because there are more, but these are few as far as the sensors are concerned. Let us go over to the last section, actuators, the slaves, and what are the different types are available for IoT applications. Just give me 1 minute. Am I audible?
Yes, sir. Yes, sir.
I'm back again. So we have discussed a lot about these sensors, then the turn of actuators. So already we have defined the actuators, physical outputs or mechanical motion we get from the input signals. And we also discussed that processor or controller is responsible for sending electrical signals. So few examples already I have told: valves, motors, and pumps. Just it is refreshing because these things we have discussed at the beginning. Now at the end, also the same thing one has to discuss. And this control signal, it can be digital or analog. So most of the cases, it's a mechanical motion at the end. So in fact, this is a different type of, this is just an example of control valve, which is also a actuator. A different type of control valves works, that is linear, equal percentage, or quick opening. Control the flow, and many of the automation flow control can be achieved by the control valve. This is just an example of that. Then few of the characteristics of actuators. What are the characteristics that limit? Weight. The physical weight of actuators limits its application scope. Sometimes we need an actuator of lightweight for home applications, and sometimes a bit larger weight. So depending upon the weight of the actuator, we have to decide the application domain. Then power rating. This also defines minimum and maximum operating power it can safely withstand. So that we have to decide in which application. Then torque to weight ratio. And if it is higher, if the weight of the moving part is higher, lower will be the torque to weight ratio. So that is a defining factor as far as these actuators are concerned. The clients, the customers can choose one. Then various actuators like the sensors, what we have defined. Here also, there are different type of actuators which is used in IoT, and the name are in your screen: thermal actuators, hydraulic actuators, pneumatic actuators, electromechanical actuators, safe memory polymers, soft actuators, and magnetic actuators. Let us discuss in brief about these actuators. Like thermal sensors, here also is thermal actuator. It converts thermal energy into kinetic energy. And it's a complete package, sensing and actuation. And it's a sensing of temperature and compared with the set point. And depending on the set point, the control can be made. And what are the applications of thermal actuators? Cooling control, freeze control, boiling point control, all related with temperature or thermal properties. And just one example, few examples are thermostatic actuator. And this is a control valve opening or closing on depending on the temperature variation. And generally this thermostatic actuator can be used in boiler controls, room heating controls, and similar temperature controlling applications. And one more is the example of wax motor. It relies on the source of heat. And particularly the wax-like substance which is used, I shall show you the sketch later on after this. It serves like actuator. In fact, wax expands or contracts with the thermal difference, with the application of temperature. And this expansion or contraction results in the generation of motion. And this gives rise to a moving mechanism, maybe piston. Have a look at this sketch, thermal actuator. So This is sketch and this is the motion. So left hand side thus a sketch and right hand side there is thermal source and there is a wax expansion and corresponding to the expansion there is a piston motion and correspondingly it will move the piston upward and piston will come down when the wax will cool. That one example of thermal actuators. What are the salient features? These actuators do not need any power supply. We have seen from the example. Sensing and actuation in a single package. Only wax for the example we have seen. And in that cases, it is very easy to deploy and unnecessary components are not required. But the drawback is that it has got large hysteresis lag. Slow speed of moving piston is one reason compared to the change in temperature. Then the next category is that hydraulic actuator. As the name indicates, it operates by exploiting the compressive property of the enclosed fluids. And as understood, it converts hydraulic energy into mechanical energy. And the applied pressure on the fluid will convert it to motion. And the motion will move the piston. And in fact, the hydraulic actuators based on Pascal law, which arises due to law of conservation of energy. And here in these cases, Pascal's law speaks that the pressure applied on the enclosed fluid is transmitted equally in all directions. Hydraulic actuators are two types, linear and rotary. Have a look at the linear hydraulic actuator. So as the name indicates, it produces a linear motion. And common hydraulic actuators are single acting cylinder, double acting cylinder, etc. See this? So there is a hydraulic pressure and there is a fluid inlet is from the bottom and there is a piston attached to it. So fluid expansion results in the piston movement. So correspondingly linear motion, there is also rotary motion. It produces, as the name indicates, rotary motion. And there are examples also, rotary vane type actuator, rack and pinion type, so which converts the mechanical arrangement into rotary motion the similar way what we have seen for linear motion. Then some salient features of hydraulic actuators. It provides high torque to weight ratio. What is the importance of this? We can lift or move, both the cases, heavy weights and application of power will be less. And also it is used where high speed of operation is needed. And also it is resistant. That means it is not affected by overload changes. And immediately the overload condition is removed, rectified, it can resume operation. But the drawback is that they require careful maintenance and periodic checks. What for? There can be possibility of fluid leaks. There can be the fluid which is being used can leak and the hydraulic pressure cannot be maintained. That is the minus point. Then in the line of hydraulic, next one is the pneumatic actuators. That was hydraulic power. Now it is air, pneumatic power. Compression and decompression of air. And correspondingly, like the hydraulic actuator, it will produce also linear rotary motion. These actuators are general in valves. And valves, as you understand, control of flow of liquid or gases. and it has got an airtight piston and pressurized air like the hydraulic setup. This is also instead of just replaced by air. So pressurized air and airtight mechanism. And this air moves the piston and it can use to lift or move the load. And after the removal of the pressure, there is a spring-based mechanism which returns the position to the original position so that it is ready for the next use. In line with hydraulic actuators, these are divided in two categories. One is single acting actuator, second one is the double acting actuator. So similar to that one, what you have seen in hydraulic actuator, have a look at this. So it has got in your screen must be the single acting pneumatic actuator in your screen right now. It has got a single port. Look at the bottom. I hope this sketch is available because MS Team takes a couple of seconds to be reflected while changes occur. So it has a single port. Look at the bottom. It has a single port and which allows pressurized air into the chamber, and it has the piston attached to it. And correspondingly, the piston will have a forward motion. If it is pressurized air or it is suck air out of the case. And in both the cases, like in hydraulic actuator, a spring-based mechanism is responsible for restoring the piston to its original position when the pressurized air is removed. Then double acting, in contrast to the single acting actuator, it does not have a spring-based repositioning system, but it has got two air inlets, one on either side of the piston. And depending upon the air burst from appropriate either of the left hand side or right hand side, the piston position appropriately. If we are letting the pressurized air from the bottom port moves the piston up, and where we are giving pressurized air from the top moves the piston down. Few of the salient features of pneumatic actuators. They are simple. Air is needed. So they are simple to design, maintain, and easy to use. And main plus point is that they are safe to be used with the environment with high fire hazards. So no electrical components are required. No electrical components are there. So fire hazard chances is not there. In contrast to hydraulic actuators, it does not have a leaking fluid. And maintenance is quite easy in comparison to hydraulic actuator. And as the possibility of leaking of fluid is not there, there is no need of cleaning the surrounding of machines and systems. That also saves the cost and time. One drawback is that in comparison to fluids, it has got lower compressibility of air. It is relatively less efficient. And it has got a long run cost also, repeated use requirement of compressed air that is needed for operating these actuators. Then next one is that electromechanical actuators. The word is electromechanical. It converts, have a look at this first line, convert the rotary motion of electric motors to linear motion through gears. So there is a thread and a lead screw attached to the motor shaft. It is active. Let us see example so that we can understand better. If we give a rotary motion to the lead screw, it's a linear motion. And so that loads can be moved to large distance. Motors can be different type, DC, induction, or brushless. And gears is generally used to reduce the speed of motors and also couple them to loads. There are two types, traveling knot type and traveling screw type actuators. Both are linear, traveling knot and traveling screw. So let us have a look at the traveling knot type actuator. The sketch must be in your screen right now. The motor is in the left hand side and it is attached to one end of the leading screw. See the screw? So it is attached to that. And there is a knot. The arrow mark gives us a traveling knot, and that is a guiding rail also. So the knot travels up and down, to and fro motion along the lead screw. And if we have got any mechanism, any moving things we require to the knot, particularly see the knot here. So it will move due to the motion of the knot. So that means any mechanism which has been attached to the knot. Motor connected to lead screw, there is a traveling knot, it moves up and down. Any mechanism attached to that will move horizontally. If it is traveling knot type, what is traveling screw type? Now the position has been reversed. The motor is not attached to screw now, it is attached to the knot. In the sketch you can see that is knot. And then the lead screw passes through the net. That means here, now the lead screw will have moving action. And anything attached to the lead screw will move. Then what are the salient features? It has got higher speed of operation and efficiency. We can control the speed so that precision tasks can be made. But this type of actuators where there is moving parts prone to wear and tear, even burnout. And these actuators require electrical power. And that involves additional cost. And we do not have additional power, we cannot serve. Then the next one. SEP memory polymers. We'll take a couple of minutes to finish it off. SEP memory polymers or SMPs. These are all smart materials, new developments that respond to some external stimulus and they change their shape. Again, revert back to the original shape once it is removed. These materials have these properties. Have a look at this: high strain recovery, biocompatibility, etc. And these SMP-based actuators are similar to our muscles. And it responds to wide range of stimuluses: pH changes, heat differential, light intensity, frequency change, magnetic changes, etc. Here, photopolymer or light activated polymer is a particular type of SMP. It requires light as a stimulus to operate. And a particular advantage of LFP based actuator is the rapid response time. It responds very fast. And it has been developed that the shape can be changed by the application of a specific frequency of light. And if we want to bring back the polymer back to its original state, a different frequency has to be applied. Then soft actuators. And also it consists of elastometric polymers and materials such as cloth, paper, fiber, particles, etc. Here the changes is a little bit microscopic changes into deformations. So that deformations is responsible for the actuation. And it has used in robotics. And also they have application in robot-assisted surgeries, manipulating the internal organs. Then magnetic actuators. As the name indicates, magnetic energy. And plus points are that compact, lightweight, and economical. Example is safe memory materials, SMMs. And one more plus point is that they do not require electricity and also not affected by vibration. So I conclude with this, and these are the references which you can use for your any sort of work. And this time for questions. Am I audible?
Yes, yes, you are very much audible, Professor Umesh.
So that brings to the end of my talk. So if there is a long journey, I have moved through different plains, different terraces, different plateaus, valleys. So I am pretty sure it is not overhead transmission.
Sir, actually, I have allowed mic for all the participants. They can ask directly by unmuting themselves.
So I am sharing. Can I stop it? I can do it again if
Yes, sir.
required.
Please stop sharing.
Yeah, right. I've stopped it. So if there is any questions, we can take it because it's a long session. So I do not know how much patience the participant has to ask a question.
Yes, it is a long session and you must be exhausted by now. But I hope participants enjoyed it.
Anyone interested to contact me can contact also. The details is there in my website. Of course, that was there in the slide itself at the end of the slide, but I unshared it. So if for future any sort of research collaboration or anything one needs to contact, he or she can contact. So it seems like that the topic was quite simple and there is no questions most early, or it has reached the threshold level of patience by listening to almost 2.5 hours, so that the mind is not working for a question. So if there is no question, we can wind up.
Yes, thank you, Professor Umesh Pati, for agreeing to us. Me and Ayaskan have been trying to sell the ship with adequate support from AICT and all the participants for being over here. What Professor Pati delivered is really interesting, and he touched some of the latest topics like SMM and particularly SMPs. And if you look at that, he has touched all the fundamentals. And if you look at SMPs, most of our participants are looking forward to IoT, and
Yes.
healthcare is a serious concern. So safe memory polymers are used for stents in the heart surgery wherever we are doing it, and they're also used for catheters as well. And so please take a note, and those are being used. So let us don't forget that whatever Professor Pati articulated through sensors, actuators, and this one is all about going to be applied in your IoT applications. And when he talked about actuators, a serious example that came up to my mind when you were talking about is saying that you are giving a signal and then coming up with an activation, more or less like your control system. Say anti-lock braking happening on a typical IC road, and then you can imagine that your steering getting locked, and you don't want then the things would go away. But then suddenly anti-lock braking would be taken care of by the actuator. So that is why it all has serious applications. Please go through all the details. And Professor Pati's first two references are by Professor Sudeep Misra, who will be over here physically on 4th December. And that book also we have will hand over to the participants as well. So once again, I thank you, Professor Umesh, for giving a 2.5 hour long lecture and with lots of patience. And now Askan, please take over, and if you want to take a photograph or whatever, please do the rituals.
Yeah, okay, sir. So I will allow camera for all. It is now allowed. So I request all of you, please switch on your camera. Sir, Mahapata sir, you have to be a bit right side of yours because you are coming, half face is coming. Attendance I have opened, and actually in today's mail I have given the wrong link. I request from tomorrow onwards you please see the 19th mail. In that we have given a link for each team session separately. And I request you to just copy paste the link in the incognito mode or in private mode of the browsers. Then the previous mode will not come, which is coming by default, and we faced a problem a bit. So please switch on your camera. I think I have allowed for all. Camera for attendees allowed.
All participants are requested to please open your camera so that your face will be seen when the photograph would be taken.
And today's attendance is still open. I have not closed it. Pratik sir, you please submit. It is open already. I have not closed. Okay, thank you all. Thank you, sir. Thank you all participants. Will please use the tomorrow session to log in to for tomorrow's class.
Yeah, thank you everyone for a patient hearing. It was a pleasure to talk to you and hope to meet you or speak to you in 2D or 3D in near future. Thank you all.
Okay, thanks everybody. So now it's time so that we can call it a day.
Okay.
As I think you can close the meeting now, right?
Yes, sir. Yes, sir. I am closed.